Okay, so let's go over the topics that we'll find on exam 1 for circuits. All right, the first thing we want to remember is that current, I, is equal to the time rate of change of charge, which is Q. All right, so that means that current is equal to the derivative with respect to time of Q, and so therefore my charge Q is going to equal to the integral of I dt. Okay, so that's what you need to remember about that. All right, Ohm's law, we should all know by now, is that V is equal to I times R, which means that I is V over R. Okay, again, really what you need to know about that. Next, we have power. All right, we know that power, P, is equal to V times I, which as a consequence of Ohm's law is equal to V squared over R, or also equal to I squared times R. All right, next up we have energy. All right, let's remember together that energy, W, is equal to the integral of power with respect to T. All right, so we're taking this power above, which we found to be VI, and integrating it with respect to T to get the amount of energy. By the way, power is units of watts. All right, and so energy is units of watt seconds. All right, the next topic you should be aware of is either Kirchhoff's current law or Kirchhoff's voltage law. What does KCL tell us? Well, KCL tells us that the sum of currents at a node is equal to 0. All right, so the sum of currents at a node is equal to 0. That means the current in is equal to the current out. KVL tells us the sum of voltage equals to 0 around a loop. All right, so these are things that we need to remember. All right, next up, we have dependent sources. And if you remember, they look something like this. All right, the diamond shape means that it's a dependent source. All right, and then inside the diamond shape, I could have either plus minus, meaning a voltage source, or I could have a arrow, and the arrow indicates that it's a current source. All right, so, or an arrow. All right, and this is a voltage source, and this is a current source. And for each of these, they can be controlled either by a current or a voltage. So CC means current controlled, and VC means voltage controlled. So in your circuit, you'll see a voltage or a current denoted to be, I0 or I1 or something like that. And then this will be like, 2I0 or something of that nature, or 2I0 here, or maybe it will be 3V0 or 3I0, or sorry, 3V0 for the current source. So basically all I'm saying is that what we have is some voltage or current source whose value depends on something else in the circuit. That's what the term dependent means. All right, next up we have combining resistors. Remember, if resistors are in parallel, all right, if we're in parallel, in other words, if the resistors look like this, meaning that they share two nodes, and let's say this is R1, R2, R3, then we find the equivalent resistance, which is located at these terminals here, REQ, is equal to 1 over R1 plus 1 over R2 plus 1 over R3 inverse. All right, so this is actually what that means. And then we also have series. And so series means that each resistor shares a unique single node. And I'll do it with 3 again. And if this is R1, R2, R3, and this is REQ, then REQ is equal to R1 plus R2 plus R3. All right. Next up, we have voltage division and current division. And since you may or may not remember this, I'm making sure that it's in here. All right, if I have a resistance R1 and a resistance R2, and I have plus minus some voltage here. All right, if I know the voltage at this node, for example, then the voltage across R2, all right, so let's say this is plus minus V R2, is equal to the resistor R2 divided by the sum of the resistances times the input voltage. All right, so this is important, and similarly with R1, the voltage across R1 is equal to R1 over R1 plus R2V. All right, so this is very important to remember how to find the voltage across a certain resistor. We take the resistor we care about divided by the sum of the resistances. This is in series. All right, current division. If I have this situation where I know the current coming in, let's say this is I, then I can have I1, which is through R1, I2 through R2. Okay, then to find I1, I'm going to take the resistor I don't care about, so R2, divide by the sum of the resistors, R1 plus R2, and multiply by the input current. Similarly, I2 is going to be the resistor I don't care about divided by the sum of the resistors and multiplied by the input current. All right, next we have nodal analysis. All right, and in nodal analysis we have 3 steps. First step is to assign the node voltages. All right, on the exam, this will be done for you. 2, we apply KCL at each of the nodes that's not 0. So by the way, this is also a part of step 1, setting something equal to ground. All right, we also apply KCL at the node, all nodes, and then we use Ohm's law to write in terms of node voltages. All right, and then number 3, we solve for the node voltages. All right, and then the last and final topic here is supernodes. All right, how do I handle a supernode? Well, first let's remember what a supernode is. It is some voltage source in between 2 nodes. All right, so this is a voltage source in between 2 non-reference nodes. And so what we first do is we write a constraint equation. And then the next thing we do is we write KCL at the supernode. All right, so that means current into the supernode is equal to the current out of the supernode. All right, and you'll see this when I do an example in a little bit.